Going to get into foldovers today. This is some of the magic of design of experiments and sequential experimentation. So just to recap, sparsity of effects, very key to making all this work. Sequential experimentation, we can strategically pick part of the design matrix to run before adding more runs and using more resources if we need to get more information. Okay, just talking about a half fraction here. We have a primary and an alternate fraction. So you look in the middle, we got design generators, or an identity for the primary fraction where it's I equals ABC, and then your alternate, we just flip the signs on that. If you put the two halves together, guess what? We have the full factorial. Why would we do that? Well, to resolve any ambiguities. Well, if it turns out that AB is significant, we want to make sure that we know whether it's AB or whether it's C there, for example. In design of experiments, what is an ambiguity? Here we go. It's just a significant effect that's aliased with some other, usually low-level effects. So we're not so concerned about high-level effects. So if a main effect is aliased with a 5-way, we don't care. But if a main effect is aliased with a 2-way or a 3-way interaction, we might want to make sure that we understand which one's the one driving the interaction. And specifically for 2-ways versus other 2-ways, we want to make sure that we're attributing it to the right effect. So for example, this is the advertising problem from lesson 24. So we have the magazine that the ad runs in is very significant to how many people recall the ad. The content of the rest of the page, very significant. And then we get this guy down here with AF. So it says AF that it's an interaction between the size and the magazine. But we right click on it, turns out it's aliased with AD, or sorry, with DE. So it's actually, it could be the interaction between the rest of the page and the layout of the ad. So how do we know which one it is? Well, there are a couple ways we can investigate that ambiguity. So the first thing is just using the main effect. So if we look back at it and we say, well, okay, F is by far the most significant, and then D. So probably it's going to be AF. We check the aliasing structure, see what else it's aliased with. In this case, we're saying, well, what if it had been BC? Then we would go and we would check it, see what's aliased, and in that case, if it had said BC, it would have been pretty clear that no, it's actually DF, because that's one of the possibilities. But in the case of our graph, we have AF, and we do want to make sure that that's the right one. So what could we do? Well, we could do a foldover. That's one of the strategies to go about breaking it. In this case, it probably is AF and not DE. Okay, now when we're talking about a half fraction, the full foldover, we can only do this on a resolution 3 design. It's going to break your aliases between your main effects and your two-factor interactions. You may still have two-factor interactions aliased with other ones, but at least this will break the main effect with the two-factor interactions, and it'll increase the resolution. Okay, so we're going to do 2 of these and put them together. Just be aware this only works for resolution 3. I'll show you why in a minute. Okay, here is a full foldover of a resolution 3. So we have our little 2 to the 3 minus 1 semi-useless design. And you can see if I equals ABC, minus plus minus plus, minus minus plus plus, and then we just have the product, okay? Down here, the second fraction, the alternate fraction, we're just using I equals minus ABC. So these signs are switched from those, but you put them together, and you're going to get the full factorial, the full 2 to the 3. And if we take this guy and we sort it, this is what we have. Here are the runs. So we've got 5, 6, 7, and 8. 5, 6, 7, and 8. And then this just tells you whether it's primary or alternate fraction. Now if we try to do this with a resolution 4 design, like in this case, we've got a 2 to the 4 minus 1, that's a resolution 4. Well, if this is the principal fraction, we have A, B, and C repeating down here in the alternate fraction, but we don't have, if you flip all of the signs, you don't get the alternate flat fraction. So if you look at this line right here, you've got minus, 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 minus. Well, that's going to flip to plus, 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 which is in the same fraction. So you can't do that with resolution 4. You cannot do the full fold over in the same way. Okay, you can fold over other fractions. So let's say we're doing a 1/16. We can pick a one factor, switch all of the signs on that one factor, and then just do a single factor fold over. So you'd run another 16th. You don't have to do the entire design. We'll see that coming up. So stuff that can be useful for your project. Sequential experimentation. So you start off doing a screening design, figure out which of your factors are significant, and then if you have any ambiguities that you need to resolve after looking at your analysis, this is how we deal with it. So your next experiment may be to go back and do some kind of a fold over so that you can resolve that ambiguity, so you can figure out what that interaction, what that actually means. So if you have a resolution 3 design, you can do a full fold over. If you have a resolution 4, you might just want to do a single factor fold over just to break that one factor out and see if it's actually driving anything. And then there's also the semi-fold, which is also discussed in the fold over tutorial. So I invite you to go do that, take a look back through the full fold over tutorial, or the fold over tutorial, because I think you'll pick up some more. And there are a few other charts back here, good visualization there for your enjoyment if you want to take a look.